With the new 6.11 kernel, we can finally use the PCI Express on the VisionFive 2. My current setup is of course a VisionFive 2 on an external power supply, the green wire neatly connected to a black one so that it is always on. The AMD Radeon R9 200 on a PCI Express riser card. And when I turn the VisionFive 2 over, you can see a neat M2 converter to PCI Express that will go to the riser card. We start with creating a directory. I will create a directory demo. And then we have to download some stuff. We have to download the image from the VisionFive from OpenSUSE. And of course the kernel. Release candidate 6. After that we can flash the image to an eMMC card and unpack the kernel. So go to directory, unpack the kernel. We also need the firmware, the blob files from the kernel, and we don't want history, so depth 1, only one depth. So now I've got the kernel, the unpacked kernel, the blob firmwares, and my image. So it is time to flash the image. Okay, flashing is completed. I remove it, the eMMC, and I insert it again. And I mount it because I need it later. You can see here my mount pointer will be different on your machine, of course. So now we can start building the kernel. And all the commands I put in here, I will put in on a website, on a blog, so you can see it. First we have to select some stuff that is missing for now. In the default configuration for the RISC-V. We miss some device drivers. And I want to load some firmware blob files because I want it in my kernel and not in the RAM drive because sometimes I will not use that. Every AMD or ATI video card have different blob files. My video card is not working with the AMD video card drivers, but with the ATI video card drivers, my video card is in between. Dus I've got both drivers and the Radeon is working and the AMD is not working. I don't know why. It was working a couple of kernels ago, but not anymore on RISC-V. But I need the Radeon binary files. If you need other binary files, you can find in my blog post how you can find them. We have downloaded the firmwares here, and it's called something like that, Linux minus firmware. Now I've got my firmwares because I need the firmwares for my drivers. Block devices, RAM drive, because I need that for Fedora, I think, and maybe for other distros. And this important one is the Zook. the input device port and the event. This one did take me a lot of time to find. You need this one to interact with your graphical environment, event X. Otherwise you don't have a mouse and keyboard. Yeah, you've got a mouse and keyboard, but it's not working in the X environment. And of course, let me see, graphic cards. Oh, I want the AT. I want the AMD. I don't want NVIDIA. Or maybe I want a boot logo. That's it, I think. Oh no, sound. Need of course sound. This is the pass-through for HDMI and display port. Need that one. If you want to use the sound card of the sound on your monitor, I want that. Some file system stuff. This one, this one. So it is needed for Ubuntu and for Snap and stuff like that. So I always activate it. And that's it. The rest is already working. Configured correctly. And what I will now do is manually edit the config file of the kernel. The reason I will do that is that I want all modules to be within the kernel and not in a modules directory, so I have to create a RAM drive and stuff like that. So I force all the modules to the kernel now and save it. That's it. So, and I think we can build it now. Oh, I've got 16 cores on this machine, not so much, but yeah. So I can add -J and 16. This is new, cool. Go for it. This will take some time. And the kernel is completed. So I've still got my eMMC mounted on my devices, so I can now copy the image to the root and boot folder of my eMMC. And of course also my DTB file that is created. Go to my root. I will create a boot command file as root because I need to be root to put here a file. Therein I will load my kernel. On my kernel address I will load my DTB file, my device tree file. My RAM disk I will use from OpenSUSE that is already on the disk. Set some boot arguments and boot it. And boot command you cannot start from uboot, but you can make a boot source file with mkimage, and I will do that. And now I've got a boot source file that I can directly boot from the uboot, so that I don't have to put in the boot commands every time. So it is now time to turn on the VisionFive Pro with this eMMC that I created. Of course, I first have to unmount it. So it is time to turn on the VisionFive2. Of course, first open the serial connection so that I can see in the screen what is happening. I still have the OpenSPE and the Reboot from StarFive, the latest version. I have written down in the blog how you can update that. I'm just booting from my flash, not from my eMMC. So now I can boot directly from my boot source file I created. And with a bit of luck, we will see something on the screen. There you have got it. Output. So the first boot takes some extra time for resizing the eMMC, of course. The root partition is now bigger. And we've not have got a graphical interface yet. We have to install it. Of course, first create a user. That's it. I've logged in with root and Linux, the default password for the root user in OpenSUSE Tumbleweed. So create a user. Of course, give myself a password so that I can log in. Also Linux. Very bad password, I know. Zipper. Update. And done. Install some libraries and programs. Finally, it's finished. I've also installed OP, so I can install codecs with OP codecs. So you can install codecs on Open Tumbleweed. This will also take a time. You can see that not all codecs will be fine for RISC-V because they are not there yet. Also ready. Now the one that takes the most time. Install KDE Plasma. Yes, all the things. And it is finished. Now you can reboot. My boot up is already messed up, so I don't have to interfere on the boot timeout. We will see some magic happening. Yay, we can log in. Okay. Yes, if I go to settings. And I go to about. Here we have got it. Working. So the conclusion, with the new 6.11 release of the kernel, I think we can boot OpenSUSE Tumbleweed directly from their image.